Hello guys, welcome to the discussion of SLMC number 13 that was held in 2023. My name is Ashwini, and before we move on, let me thank uh, the graduate of the University of Peradeniya, now a demonstrator, Mr. Akalanka Chandralal, who helped me with the discussion. And without him, I wouldn't have been able to do it in a very short notice. So let's dive into the problems. And what I want to tell before we start is that Olympiad problems do not have a method. Okay, so you don't really have one way to do one problem. It is always case by case. So when something happens, and also you have to do it quickly, which means uh, you'll have to optimize time. So sometimes you would go by the hunch. So sometimes you will have to do a very quick computation that is not based on theories. Okay, so keep all these in mind. And how would you get this ability to get this hunch is by doing a lot of problems. So you could see in the OMF website, there are plenty of MC questions that you can try, and all of them are very fun to do. And you can start from the very beginning, and you will see that as you do it, keep doing it, things become a little more easier because your brain gets trained to solve these type of problems. And again, as I mentioned, it is very fun to solve, unlike some problems that you encounter in your day-to-day mathematics learning. So let's dive into these problems. So this one right here, when each of digits 3, 4, 5 are placed in a square below, the sum of each two-digit number is formed. What is the largest possible sum? So if I want to have a larger sum, I would put these numbers on the tens place. So I can put 5 here and 6 here. And then that leaves me with 4 here and 3 here. So again, it's a resource optimization problem, how to use these resources optimally. So if the problem is about getting the least number, so you would put 5 and 6 on the first ones position and 3 and 4 in the 10th position. So here you can see the answer is 170. Okay, let's move on to the question number 2. Digit sum of a number is a sum of its digits. How many two-digit numbers have the digit sum of 6? So we have to start from something bigger than 10. So immediately I can see 15 is one of them. Now I can see the pattern 24, 33, 42, 51, and 60. So there is no theory, just count them up, you get 6. Moving on to question number 3. Question number 3, uh, someone is traveling from A town to B town and passes by two indicative signs along the road. One of them is a hidden number. What is that number? So when I encounter a problem like this, I can probably start with a point 0. Okay, so that is my 0. And I have a number line like that. Okay, and I can see here B town is 9 kilometers and here B town is 2 kilometers. So this is 9 kilometers and that must be 7. And A town is 4 kilometers to the other side. So by this representation, this should be -4, which means I just have to compute this distance. And that would be 11. So this would be 11. Okay. Moving on to the fourth question. Two corners of a square piece of paper are folded into the middle of the square and following pentagon is formed. Okay. And let's see what happens here. So when if the area of the pentagon and the square are consecutive whole numbers in centimeters squared. So let's actually get the square. To get the square, I have to unfold this. And when I unfold this, I can see that there are 8 equal pieces, 1, 2, 3, 4, 5, 6, 7, 8 that are there. So so let's keep that 8 there. And now I fold it, I get 1, 2, 3, 4, 5, 6 pieces. So that would be 6 here. So the ratio of the big square to the smaller pentagon is 8 to 6. So now I need to find two numbers which is in the ratio of 8 to 6 but are consecutive immediately. You can see 4 and 3, which means 3 is the, I don't know whether it's here, but 3 is the number that is the area of the pentagon. Moving on to question number 5. The triangle ABC is equilateral and has area of 27 centimeters squared. And in this question, everything seems perfectly working. So you can just do this. And because of the equilateral part, and it divides the sides into 3 equal lengths, all these things should be equal. Okay. And as you can see, there are 3 pieces. So it's 1/3 of the whole triangle and the whole area is 27. So the area of the unshaded part is 9. Let's move on. What is the least number of circles that can be removed from the following figure so that none of the circles intersect any other circle? So if I want to remove the intersections, I would start removing the circle that would intersect most of the other circles. So that would be this circle. So 1 is not an answer. So it should be at least 2. But you can see when you remove the second circle, 4 circles, the other 4 circles will be untangled. So I would say the approach would be removing the maximum intersecting circles. Let's go on to the question number 7. How many 4-digit numbers are there such that the hundreds digit is 6 more than ones digit? So this is a format of a 4-digit number. And this right here can have 9 different choices because 0 cannot be there for a 4-digit number the first place. And then the tens digit also, it can have 10 choices because you can have 0. And these are dependent. For example, if it has 0, you should have 6 here. 1, 7, 2, 8, 3, 9, and then stop. These are the only possibilities, which means you have 1, 2, 3, 4 possibilities for that, and then 9 possibilities for A, and then 10 possibilities. So you have 360 total possibilities. I believe it was something over here. Okay. If in the following figure, the areas enclosed by the egg-shaped circles can represent different number types. Which of the following? And we have multiples. Multiples of 4, multiples of 12. So whatever multiples you have to have 0. So 0 should be in some of this. So I will say 0 is there. Okay, which means this can't have 0. And when you look at the choices, the only thing that doesn't have 0 is where you have prime numbers. All the others have 0. Therefore, this is the choice. Okay, let's move on to the question number 9. You have a 10 by 10 grid, sides of length 3 centimeters and 4 centimeters. So let's say this side would be 30 centimeters and this side would be 40 centimeters. And you are allowed to go vertically or horizontally. So you can do like that, or you can do like that. And you can see no matter how you go, you will have to go 10 steps this way and then 10 steps that way. So you will always have to go 30 plus 40 equals 70 units of length. Okay, and that would be, the second one would be right. Irrespective of the path, you will always have to travel 70 centimeters. The distance and cross by crawling vertically up and horizontally right is longer than any other distance. That's wrong, because all of these are same in length. If the ant crawls along any diagonal of a smaller rectangle, so if he goes that way, you would go in 5 units rather than 3 plus 4 units. So you have 7, you have 5 instead of 7. Okay, and that they can reach in a distance less than 70 centimeters, and that's true. So 2 and 3 are. Okay, so I'm going to segment this video into 3 parts. The easiest ones, the medium ones, and the harder ones. So these are the easiest ones. So let's finish with this one right here. In the scales, the 5 balls labeled A, B, C, D, and E weighs 20, 100, 100, 100, and 120. Okay, so when you look at these two figures, I want to save my times, and when I look at this, immediately I can see that I want to focus on this. And 3 of them should be the sum of 2 of them. And the only choice would be 100 and 120 paired. That would be 220. And then 100, 120 paired. So 100, 120. Okay. And so E or B or C must be 20. So immediately I know what is at least 3 choices of 20. Now moving on to this one, I can see that E plus B is bigger than A plus C. Now, also I can see that A is either 100 or 120. So the choices of A are 100 or 120. And either case, if you have C to be 100, okay, if you have C to be 100, then either E or B must be 20 and the other one should be 100. So this is 120. And you can see that it cannot be heavier. Okay, which means C must be the lighter one. So C must be 20. And very quickly verify, because the question is well formed. If you have one answer, that should be the answer, 120, and fine, and then 100, 100, and then our thing should work. Therefore, C is the answer. Okay, so I hope you enjoyed this part, and I hope you can just go solve questions 11 to 20 and then come back to and watch the second segment of this video. Thank you so much for joining us. I'll see you soon.